Recording in progress.
Please go ahead, ma'am.
Good afternoon, everybody. We welcome all participants to the third in the series of Mass Timber Construction in Nigeria webinars. Sorry, I'm getting a feedback. So this webinars introduce stakeholders to the ecosystem of mass timber. They're taking us through the complete circular economy of the product as a sustainable construction material because of its ease of fabrication and its environmental qualities. We have had two webinars so far, namely Introduction to Mass Timber Construction and Forestry, how to prepare the forest for mass timber construction. These webinars were taken by industry experts who took us through all that we need to be introduced to. Now, we shall be having 3 more webinars after this. We're trusting that you will join us. It's hoped that you will find these topics being presented today very useful, and you will gain more insight into the concept of mass timber in construction. All participants are encouraged to put their queries, their comments, and questions in the chat box, and also to record your presence by writing down your names, your email address, and where you're joining us from, so that eventually we will be sending certificates of participation to you. We hope you will enjoy these topics that have been presented by our very veritable experts again. You're most welcome. Our first topic will be presented by Dr. Paul Kremer. Dr. Paul Kremer is an associate professor and he has been instrumental in evolving the construction market in Australia and New Zealand over several years. In more recent times, he's been working specifically in the pre-built and panelized construction sector. More recently, Paul worked with XLAM, Australia's first cross-laminated timber plant. Paul is an adjunct associate professor in engineering at the Deakin University, a research fellow at Melbourne University in the Department of Infrastructure Engineering, and is also a researcher in mass timber at RMIT University in Melbourne, undertaking research and supervising masters and PhD students. Paul is a published author with several peer-reviewed papers. He's a Gottheim Fellow and the founding editor of Mass Timber Construction Journal, as well as the host of Mass Timber Construction podcast. Let's welcome Dr. Kremer to make this presentation. Thank you.
Hello everyone, sorry I can't be there in person to give this presentation, so I thought I'd record the presentation and it can be played to you. If you have any questions at the end of this particular panel, I'm more than happy to take an email or through LinkedIn and you can ask any questions, but I thought I'd like to give you an Australian perspective on cross-laminated timber in a highly automated plant. We use a very different species in Australia and I'd like to walk you through that now. But before we begin, let's have a look at what mass timber really is and where the sort of genesis came from. Mass timber's commercial origins did come from Europe and it has been used extensively in Europe. But the earliest patent we've got is 1923 for this product called composite laminated timber or composite lumber. And it essentially is cross-laminated timber using smaller board pieces and compression systems to be able to try and improve a composite of timber to make it have a higher capacity for two-way action, so that's the transverse and the longitudinal lamellas, and that then gives it its dimensional properties which are greater than a single board can give in say one orientation. And so this pattern is really the first semblance of mass timber, I guess, from Tacoma in Washington State in the US. But more importantly, now we define mass timber as being something more of a commercial element and part of the superstructure. And so mass timber really does replace wet pour concrete or reinforced concrete systems, and really forms the new age renewable technology superstructure. And as you can see in this model here, the remainder of the building, whether it be the concrete screed on top of the CLT floor systems or the plasterboard ceilings that have a plenum area and have they look to have some sort of post-tension beam system running through them, and timber columns, this is representative of what mass timber looks like in modern technology. And it's important to remember it's not just the material type, it's also the process. The process of prefabrication is what gives mass timber its competitive cost advantage and time and speed advantage edge. In terms of the material, its lightweight, its stiffness, and its strength capacity differential based on the dimensional depth of the material is another reason why you would use it. And it's lightweight. It's a quarter of the weight of, 20% of the weight of concrete. Let's have a look at the global expansion of mass timber construction, because I think it's always important to see where we've come from. Back in 2011, this was sort of the landscape. There was a little bit going on around the world, but 2011 was quite an important year because this was the year that Lend-Lease took the technology out of Europe, specifically out of the UK, and the Stora Enso effectively provided the material for the first building in Australia, which is the Forte building, which is a 10-story, 1,000 cubic metre building. And we had a plant set up in New Zealand as well, in a place called Nelson, through XLAM in Australia and New Zealand. And so 2011 really started the genesis of the journey for a commercial way of viewing mass timber. And since that time, what we've seen is the expansive growth all the way through to 2023. And now there is a significant portion of people who are using mass timber construction, and there's a number of plants coming online. There's 2 plants in Australia right now, and there's just a growing movement happening in the US and Europe and around Asia Pacific, and obviously in your area where you're trying to secure enough information and intelligence to support efforts in your country. So how is it made? Well, let's have a look at a short video and see exactly how it's made. This is a video of the XLAM factory, and I'm going to narrate or talk over the top for you. So this is the XLAM fully automated press, and what you'll actually see is the boards coming in. They're laid up on this like a deck to be able to allow the boards to get sorted into individual items, and they get tested for moisture control. So we want to make sure that we have the right moisture content in the boards to be able to allow them to go through the process without an issue. This is finger jointing one end of the boards so that we can actually create a continuous length, and the ContraZinc here not only feeds the boards in continuously, it runs a finger joint through, and in a moment you'll see the glue being applied to the end of the finger joints right here. And that means that we're actually able to join continuously all the boards. They come down and then they get pressed together. The ContraZinc brings the 2 boards together and makes sure that they are joined in one continuous run. The flying saw here, the red saw you're about to see, cuts the boards to the length that's required, and they run down this conveyor system into a multi-level conveying system, which actually allows the glue within those finger joint systems to dry. And here you can see the boards all being sorted out. Some will become long boards for the length of the billet, and some will become the cross boards, which is for the transverse lamella. It goes through the system until it has enough curing time for that glue, and then it will actually go into a planing and a almost like a finishing type room to make sure that the dimensional depth and width is appropriate for the type of billet. So any variability in the boards effectively gets planed out and they get machined down to the right size. Once they're machined, they get cut into lengths that are required for both that longitudinal and transverse. Here you can see the short boards, so these are the cross boards that are being loaded onto a conveyor system in an array so that they can get picked up by a vacuum lifter and put down onto the pressing bed, which is where they will be glued together before they end up in their final resting place in the press. The boards are now traversing along. The cross boards come down onto the bed, and you can see that happening here. These will go on top of longitudinal boards which already exist on the plastic tray. As you can see now, we've got the first set of boards being picked up. The white centerpiece is actually the bed that they will be laid down on. And these vacuum lifters are very good at placing these boards on in a good way. The whole table now will move so that the glue can be put on it. Now the next layer comes on and it goes on top of it. And you're always going to have odd numbers of layers. Now it'll go back through the glue machine, which is where those purple lights are. You can see it here, the glue being applied. And there's two boards on there, and they're two different thicknesses. And at the moment, the short boards are on the outside. So that tells me that this is a column orientation for this particular panel, not a floor plate. They then go into the press, and the press creates the pressure that's required to be able to make sure the panel stays together. And here it comes the panel out of the press. So it's had its curing time. It cures outside the press, and it also cures under pressure in the press. And you can see the glue has foamed up now. That's because it's reacting with the moisture in the timber. So the moisture in the timber is required to be able to work efficiently to make the glue set off. Here again, it goes into the press. This is the next billet, and it will now compress down and ensure that the whole billet comes out. And that's the end of the video for this particular bit. Let's have a look at what it's like to have detailed design around those panels that you just saw being made. Now the first part is a digital design. To take that product that we've just produced into ordinary panels, we need to make sure we arrange them in the right way. You can arrange them through a number of different perspectives. So the first one is that you can use Revit to do a architectural space and place model. But more often than not, Dlubal or Tekla are the next elements for the engineering analysis to make sure that we've got all of the right engineering properties for the building structure itself, for to avoid catastrophic failure, to ensure diaphragm, to ensure we've got load transfers, etc. And all of that's done in Dlubal. We have this interoperability aspect where we can take what's called an IFC and change it from one program and put it into another program. And here you can see that there's deformation stresses being put on the building, and so the red is a higher level and the light green is a lower level. And the software is able to be interoperable, so we can take it from Revit Autodesk straight into Dlubal and then back into Revit Autodesk. And so to give you a practical example of how this comes together, we're going to look at this particular model. And this model here is of a building. I'd like to say thank you to Franco Piva because he's given me this model to use in this video. And I'm going to walk you through what the model looks like when we do a fly through. And as you can see now, we're going through the building, looking at all the individual elements. And now we've come out the other side and we've transformed the digital version into an actual building. And if we take those same fly-throughs with this particular building, you can see that where we had a digital technology telling us where to place the panels, those panels have now ended up on site, and that building is coming together in almost an identical way to what it was in its digital space. And you can see the final building before the cladding and the aligning goes on. And here you can see the final building with the cladding going on and the windows going in. And if we look at them side by side, you can see that the building looks remarkably like the digital model that we had prior to that. So it's really important to know these digital models really are the genesis for where the technology is placed when it comes to understanding how mass timber buildings come together. And so mass timber systems can get used in very different types of buildings. And one of the buildings is in Spokane in Washington State in the US. And it's the Catalyst building, which was actually done by Katerra before Katerra unfortunately left the planet. The Catalyst building has a Revit model here. Again, we start with that Revit model to see exactly where the place and space for all the panels will go. And then we work into more sort of detailed orientations for each of the panels that we produced. As you saw in the factory at XLAM, each of those panels has a location in a digital model. That digital model then allows us to make the panels appropriate for the type of floor system or the type of wall structure system or column system. Once we have that detailed design, we can actually then do a what's called a shop drawing list. The shop drawing list lists all the panels that we need to make, and this is what's sent to the factory to produce those different types of panels that you saw being produced in the video. And we make each one of those and we put them together in digital space. And here's that digital space. This is the column and beam structure in the green and the yellow at the top. And then we have what's called the intermediaries, which is this orangey red that's sitting in here. And so that model gives us the structural skeleton of the building, which we can then go and lay the panels onto. Now, the panels might be CLT panels, or they might be a hybrid cassette system. And the columns may be steel, but they may be a higher grade glue laminated timber technology. And in most of these buildings, and in particular this particular building, the green beams are actually GLT beams, glue laminated technology beams. Once we have the whole superstructure together, you can see these purple panels. These are the facade. So this is a modular facade system which chased up the building, which means that when the building levels went up, so did the modular system. And all of that's produced in a factory. In fact, this is the factory that produced the Catalyst building. And as you can see on the bottom there, that factory looks remarkably similar, except for it's a hell of a lot larger than the one at XLAM that I was involved in. Once they have the panels already sorted out and ready for production, you then need to work out how you're going to transport these panels. And one of the ways we do that is to break the building down into zones. Once we break the building down into zones and we know which panels go into which zones, we can load trucks up to be able to deliver them so that when they get installed, they go in the right sequence. And as you can see here, I mentioned before that there was glue laminated beams. Well, this also has a CLT lift core. These stair cores in the center of the Catalyst building are also CLT. Generally, you find that that's often concrete because regulations in locations like the US and Australia and Europe often don't allow that to happen unless there's a really good fire suppressing system and a building regulatory certifier that's comfortable with having CLT or mass timber cores. It's an impressive building. And here's some under construction shots. And you may have seen these types of shots around. There's a lot of these photographs that are around looking at this building because it has these massive beams and these intermediary ribs and wonderful columns, and the entire building just looks amazing. Again, some more great shots with the facade system, and you'll see the facade system's actually CLT as well. and some more in construction shots from a distance. And so that's the Catalyst building, and the world's largest volume of CLT in a horizontal building belongs to the NTU project in Singapore. And this is a Stora Enso project and VHAG. And the building has just opened recently, and there's only been a few photos that have come out. So I've got the original modeling photos. And so the massing project shows this pretty massive curved building. It's in the south sort of business area of the university, and it is an impressive site. This is the wooden model that was produced to be able to verify the location and the placing of the building, and another angle is given here. Again, the systems are very large. They're these very large connection systems with amazing glulam beams and these hidden connections like pixel connections. And so Suguru Ban, who was the gentleman who worked on the design with this, had this very concealed fixing systems, and these were the size of those systems that went into the NTU. And as you can see in the Catalyst building, they've used something very similar. This is using material that is in the Katera building that you saw previously, but it follows a very similar unique design in the NTU building, and this is from the NTU building. So this building is now open, so if you do get a chance to go to Singapore and do get a chance to go and have a look at the NTU building, you will not be disappointed at all. It's an impressive building. So that's my quick run through in sort of 20 minutes of the mass timber production, all the way from how we get the boards to be put through the machines to be able to then go into a press, and then how that panel is then situated in a digital technology, and then how that is configured to go to site. So I've actually given you from the board or the tree all the way through to the completed project in a very, very short walkthrough. If you want to keep in contact with me, you can jump on LinkedIn, and I also have the Mass Timber Construction Journal. This is a two-faceted journal. The first one is an academic journal, so we publish papers that are on science of mass timber and exclusively mass timber. And the second part is we have, through LinkedIn, we report every project that gets published around the world. I do a podcast every week, and I've been doing this for almost 3 years now, and I promote what's happening around the world in mass timber land each week. And also on top of that, we do the social media feed, which is through LinkedIn, and it's all the news articles that we do report on the podcast. The podcast also has special guests coming on. So the special guest just recently is Amanda Sturgeon, who was ex-Living Future Institute. She's now at a company or an organisation called Build by Nature, and that organisation issues grants and does philanthropic work to be able to try and promote mass timber construction around the world. So if you do feel inclined, please come and get in touch with me about the Mass Timber Construction podcast. If you're interested in any media, we have a prospectus that's available at the same time. And if you want to get in touch with me, that's my email address, and they're my associations. And I just want to say thank you so much for allowing me to present today.
Thank you so very much, Dr. Kremer, for that insightful presentation. Again, we welcome all our participants to this webinar. It is Mass Timber Industry. How do we process trees to create engineered wood products? So Dr. Kremer has taken us through the first step. Our next speaker is Jenny Smiley. He will be coming up in a moment. Now, Jenny Smiley is the founder and the director of Exlam South Africa, the first manufacturer of cross-laminated timber in Africa. Jamie's experience working as an architect prior to establishing Exlam South Africa helped him to identify some of the problems and solutions that are facing an increasingly stressed construction industry. With their offering of cross-laminated timber, architectural and engineering assistance, CNC machining, and offsite manufacturing, the company aims to make the construction process easier, faster, and more predictable. The company Exlam was established in 2018 and started manufacturing in an environment that had no immediate demand or standards in place. Through their journey, they had helped implement a national standard for CLT and grown a market that is quickly expanding. They have supplied CLT for over 100 projects, ranging from small residential to multi-story commercial and institutional buildings. The company had supplied projects in South Africa and exported to other countries in Africa. Jamie's company manufactured much of their own machinery and systems, including their vacuum press system and robot CNC cutting solutions. It has also assisted in the establishment of mass timber production facilities in other parts of the world. While still quite a small manufacturer with a capacity of about 1,500 cubic meters annually, they have shown that there is a place for small-scale manufacturing of CLT products, which can allow for organic growth to meet market requirements. Jamie, you're welcome, and you can start your presentation now. Thank you.
Thank you very much. Thanks for having me. I'm just going to share my screen to show our presentation. Can you see the presentation? Hello?
Yes, we can.
Yes, we can.
Okay,
Yes.
that's great. I thought I was on my own for a second.
Yes, we can see.
So yeah, we are a manufacturer in Cape Town, South Africa. We've been operating for about 5 years now. When we started manufacturing cross-laminated timber, we were the only manufacturer in the market. In fact, there wasn't really a market here. There were a few European companies who were trying to export stuff to South Africa and a few buildings that had gone up, but nothing that was really in an affordable range, and quite difficult to manage those projects over such a far distance. It is possible, they do it quite often in Europe, but the market here wasn't really something that they were focusing at. So I did a trip around Europe and visited a few of the factories there, and I must say that they were very helpful and friendly in helping us to get the information that we needed. And then we decided to start manufacturing. So my background is in architecture. I was an architect, so I did have an understanding of what the market required. And I had also managed a furniture manufacturing facility, a timber furniture manufacturing facility. So I kind of already was in the pathway for that. We initially started by building our own press. So we had looked at purchasing machinery, but as you can see in the videos, the European spec type of manufacturing facility is a huge capital cost. You're talking tens of millions of dollars to set up a facility like that. But we have seen that there's a way to manufacture cross-laminated timber on a smaller scale. And for the African market and a market that's kind of just starting off, we think that it's a good option to an easy entry into the market. So let's take a look through the slides that we have here. We, from the beginning, wanted to make sure that there were certain elements covered. And because we were first to market and the first manufacturer, there's a lot of hurdles or barriers to entry. The biggest barrier was the standards. So I'm sure Nigeria has its own specific building standards and recognizes certain materials. South Africans has SATIS or the SANS standards. And to build with materials which aren't in those standards is quite challenging. You get a lot of issues during your submissions to council and for approvals. So it's difficult to get it through. So the first stage that we saw was to tackle that standards. And to get a national standard in place is not an easy task. And we actually helped one of the universities here, one of the big universities here, to push it through. There was also some backing by the certain government organizations. They can see that the Department of Trade and Industry in South Africa had already identified mass timber and engineered timber as an important product, which would increase the forestry sector, which makes up 1% of our GDP. So with the university and with kind of these parastatal or these state organizations, we managed to push the standards and get something in quite quickly. So quickly is 3 years, but we still did get something in. So South Africa now has a national standard, which is actually a copy of the Canadian and American standard. It's a clone of that. Also very similar to the ISO standard. So yeah, you know, it is a good standard because it is relatively easy. It's not a huge document to get through, and it is the ISO standard as well. It's pretty much equivalent. So the SATIS is the certification we got. The other key things that we needed to make sure of was that our timber supply was coming from sustainable resource. So we are actually FSC approved and make sure that all of our stuff comes from a sustainable resource. And then we had to check the timbers that we could use to produce CLT here. So I'm not 100% sure what timbers would be used in Nigeria, but in South Africa, the major plantation timbers are SA pine, which is a mix of kind of radiata pine, Eliota, patula, and then quite a large portion of eucalyptus, grandis, and saligna. So the pine is the cheaper option here and maybe the more suitable option at the moment. And we went for that as our major material, but we do eucalyptus panels as well. We also found that fire was a huge issue. Like it's not an issue with the mass timber itself, but it was an issue with the certification in the country. So there's a lot of documentation and information about how good mass timber is in a fire situation and how it will stand up and all of the properties of that. But because there wasn't a South African version of this, a local study of this, it was causing trouble. So we actually went through the universities again and got a study done like that. So these are kind of duplicate studies of what's been done internationally, but I think it's important for a country to have its own standards. It makes it much easier to pull through. This is just a diagram about what CLT is. I'm sure you all understand this already. We manufacture from SA pine, as I said, and we built our own press, which is a vacuum press system. So the vacuum press system, it works on differentiation of atmospheric pressure and kind of sucking of the panel down or the evacuation of the air rather than the larger production machinery, which is kind of what was just shown, the hydraulic presses or the pneumatic presses. So the hydraulic and pneumatic press are amazing, very strong, give you an incredible product, but they come at a huge cost. And they need a lot of kind of support machinery in order to feed that press, because for the price that it is, it's got to be producing constantly. We found with the vacuum press, we're not going to get close to the production volumes that a larger factory like the Exlam Australia guys would, or the Binderholz guys would. We are a small scale manufacturer, but we can grow quite easily. and at quite a reduced cost of entry. So I wouldn't say that the vacuum press is any better than the hydraulic press. I probably think in long term, a hydraulic or pneumatic press is better. But once you're building up to a certain volume, maybe 10,000 cubes or 15,000 cubes, then it starts making sense to move across to another one. So it is possibly a stepping stone and an easy entry. There are some big factories in Europe that are using vacuum press. It is still a great system and you can use it for high-end production. There's a whole range of mass timber products, glue laminated timber, dowel laminated, LVL, parallel strain, nail laminated, all of the different ones. We specifically have focused on cross laminated timber. It is very similar to glue laminated timber in its production process up until the actual pressing. So there is possibility to do both of these, but we specifically have just decided to focus on the cross laminated timber. Again, this is just the standards. We had the standards in place. We got the fire certificates and testing done, and we have structural testing done. So we had to cover all of those bases with the materials. And in any new environment, this is kind of the key things that you have to do. You have to identify the timber and start getting these standards in place. We did manufacture before we had standards, and we actually built quite a few buildings before there was a standard in place, but it just makes it that much easier once there is a standard and it is a recognized material. Mass timber got huge potential for solving a lot of problems that are found in the construction industry. And it's not all about the timber itself, it's kind of what the timber can do in its system. So because you are manufacturing off in a factory and to different levels in a factory, you could do just the panels, you could do full build-ups with the cladding on it, or you can, and we have done before, entire modular buildings which are then transported to site. So that allows you to increase your construction speed quite considerably. The material is kind of a finished material as it is. It is a structural material. We found there's a lot of issues here in South Africa where people see this CLT and they're looking at kind of ArcDaily and those type of websites and seeing beautiful CLT. It is a construction material and it is ideally a structural material. So you can use it as a finished material, but it does take some additional work onto it to make it look good. Carbon sequestration, the environmental side of CLT is a whole story in itself. It is kind of the only industrial scale green material that we have. And then, yeah, one of the big bonuses with this type of material is the ability to cut and machine it to very precise shapes and sizes. And this is kind of what you were seeing with the BIM models and the 3D models, where the drawings are coming from architect to engineer to the factory where it's being built. And it's the same drawing the whole way through. We use the same model in each place. So there's also a huge reduction in issues that come with building, the transfer of information and errors that can come in drawings. And so it helps to streamline and make those processes a lot more predictable. This is just kind of a basic explanation of how the projects are planned. I was an architect myself, and I was guilty of it. A lot of the time we would design buildings, and even while it's being built, you're still making changes to the design and updating things. This type of system doesn't work like that. You have to put in that pre-planning process to get the most out of this. If you can do that, your project is going to run beautifully. So it's quite important to have that level of detail, LOD stages in a project, and to be able to look at those. Project must be frozen before it goes to the manufacturing. You don't want to start making changes while panels are in a factory. Then there's different levels of development that a building could come from. This is a detail from Stora Enso showing different ways that they would do it. You can have just flat panels or panels with cutouts. These could be made up into then composites, which are, say, a cross-laminated timber wall with the cladding on top of it, or to the level where you're doing full build structures with glazing and electrics and plumbing and everything incorporated. And that's kind of what you're doing in the factory is at that level, you're screwing these things together and building components to different levels. So yeah, so you know, the explanation of how cross-laminated timber is made was very good in the previous presentation. I don't think we need to go too deep into that. This is just kind of showing the different levels of the actual manufacturing. You know, you can just be a CLT manufacturer and not do the sub-assembly value-added portion, but it does help. It's a great add-on to be able to have. This is just a basic run through to show the different processes that are involved in manufacturing cross-laminated timber. You know, the moisture content is one of the key issues with the timber. We manufacture our timber from pre-graded structural timber, so it already is graded as a structural timber before it arrives in our factory. There is the possibility to do that within the factory. Moisture content, very important. You know, you have to do equilibrium of moisture kind of for your factory, and then also keep in mind where it's going to go in the end. The main components of a factory, I would say, is kind of your finger jointing operation, where you are taking planks and extending them. Then there's cutting them to length. Then you would do your molding, typically, where you're putting the planks through four-sided cutters, so you can get very accurately planed all around timber. Then you can do your layups with glue and pressing. So in the previous presentation, you saw that the factory there is highly automated. Our factory has almost no automation. We are kind of hands-on manual the whole way through the process. You know, we've got 15 people in the factory. It's a lot of manual labor, moving timber across from station to station. The layup itself is done by hand. The glue application, we're using the polyurethane glues, but we have kind of a gantry system that is moved through a small motor rather than a fully automated gantry system. So there are ways to find easier entries into the market. You know, the more technology and testing and automation you can put into the process, the smoother it's going to become. So our operation, it takes a lot of kind of hands-on, eyes-on to make sure that the product is coming out the way that it should do. So I'm not saying that having no automation is the right thing. I would think that having more automation is the better thing to do, but you can build up to that automation. The one component which is kind of essential is the cutting. Making CLT is one story, or even before that, the engineering and design and drawing and preparing the packages for manufacturing is one story. Manufacturing of the actual panels is another story. And then cutting these panels to a specific size is a big story. We initially started by cutting panels by hand. We had big circular saws and routers, and I can tell you that it's not a good option to do. For the size of the panels and the weight of these panels, you need some form of automation and some sort of mechanical cutting system in that operation. So here you can see the press, kind of the comparison of the two press. The bottom one is the Liedernick X press. That's kind of the press that XLM Australia, I believe, have. Made in Slovakia, an amazing piece of machinery. The one above is a Woodtech vacuum press. That's very similar to the system that we have. It's kind of a rubber membrane that goes on top of it and sucks the panel down. You can see in the back corner that there's one shown there. Cutting of the panels, we have opted for an industrial robot. So there's two systems that you could use for this. The one is a large CNC gantry system, and the other is an industrial robot. So the large CNC gantry system is essentially what it says. It's just a supersized CNC with very big motors and tooling on it. This kind of is almost a fully automated system. You can put the drawings and the panels in there and cut exactly to the sizes that you need. A system like this is an expensive system, justifiably so. It's a very high-tech system. The option that we have gone for is of an industrial robot. These are the type of robots that are used in car factories and are a lot more accessible. There are quite a lot of them around, and the second-hand version is very good. This is our robot. We actually purchased it from a BMW factory. The robot system does take a lot more input from our side, but we luckily have had help from Autodesk in programming these robots. So we use this with automated sliding track to be able to cut our panels to lengths and to sizes and to do the detailing. And we use a circular saw and a large router. So we can do probably 70% of what a large automated CNC could do. Kind of these type of things. This is just some of the projects that we've done. This was the Deloitte building in Cape Town. Those were CLT pre-manufactured facade panels that were made off-site and then put in. That's kind of the inside of those panels where you can see the CLT exposed. This is the pre-manufactured type of units. These things were built in the factory, glazing, electrics, plumbing, everything incorporated and then lifted into space. That's kind of one of those units. This is also, it's kind of limited to the size of the unit that you can transport. So, it does need to be a modular system if you're going for larger sizes. But that you can see is kind of the fully exposed CLT internally. Like I did say, it is a structural material, but you can make it look great if you put a bit of extra time into it. This is more typical of what we do, is just panels for houses. They arrive as flat panels and are assembled on site. This is another project. So you can see even with the machinery that we have, we can manage to make panels up to kind of 200 mil thick. With our press system, we do an 8 meter by 2.7 meter panel. We are planning on building a larger press, so you can get 14 meter panels. But again, transport is a big deciding factor of the size of press that you would need. Lightweight, it does allow it to be combined with other materials. It works very well with steel. Kind of the accuracy in the steel and the timber complement each other. And then even large scale, we do a lot of floor panels. So I think it's an African situation where the cost of labor is kind of low here. So it is not that expensive to get people doing brick work on a building site, which makes it a little bit difficult to compete with that type of material. But for reinforced concrete slabs, we are very, very competitive. That's that same project from the internal. You can see this is incorporated with glulam beams and CLT panels. And then, multi-story buildings. The speed at which a CLT building goes up it's mind-blowing. Every time you see it, you can't believe it happened so quickly. So this is a double-story building on a very difficult site, and that's about 3 days worth of work to put that entire building up. And that's us, we are Xlam South Africa. There's a few Xlams out there, but we are Xlam South Africa. And I'm Jamie, and that's my email address and contact details if you would like to get a hold of me. And thank you for having me.
Thank you so very much for that presentation. Without much ado, we'll be going into our third presentation. Jenny Smiley has just presented, and we will be inviting Wolfgang Abenstein to join us shortly. Sorry, Wolfgang Habenstreet. Wolfgang Habenstreet is a talented and goal-driven man of many parts. He's currently the head of international sales at Binderholz Bausystem in Austria since 2020. Before then, he was the organization's sales manager within continental Europe. He had walked through Italy, Spain, France, Portugal, Belgium, and the Netherlands, where he deployed a decade of professional experience in sales, advertising, as well as investigation and improvement of the sections of the organization. Having worked in the technical office of BBS and with a background in carpentry, from which he had gained experience in preparation, fabrication, and construction of wood structures of various building types, as well as execution of various projects. He directs the understanding of the sales guide procedure with a keenness to support the training of the company sales teams in order to achieve the company goals. We welcome Wolfgang to make his presentation right away. Thank you.
Hello, everyone. Thanks for having me.
Hello, good afternoon. Yes, good afternoon. You're welcome.
Everyone already sees my screen, I hope.
Yes, we can.
Yes, we can see you. We can. Thanks.
Perfect. Short overview about our company so that you know with who you're talking. So we have different operations around the globe. At the moment, around about 60 factories overall. We are 6,500 people with a turnover of about 2.5 billion euro. The company was founded in 1950 and is 100% family owned and family managed. Before going into the details, as we already had heard a lot about the CLT production, I will take the topic, how do we process trees to create engineered wood? And first of all, I would jump into a general point. Typically, we have the timber divided in two species, if we want to call it like this. Conifer, needle tree, softwood, how it's often called, or leaf tree, hardwood. Typically, we only work in the sector of the softwood, so which means spruce, larch, Douglas, and pine. That's also the timber that is normally used for the construction. Hardwood typically is used for flooring, high quality interior, and so on. Reasons for it, let's say, normally the softwood, as the name already says, it's softer. That means it's easier to process through the whole chain. So not only in producing, I need different machines, but also on, for example, on the assembly. Through a softwood, I can easily drill a screw through a hardwood not. I would always need to pre-drill. So differences, I think everyone probably knows a little bit. Softwood is light and it almost looks also light. Hardwood typically looks dark and is way heavier. So basically in our method of construction, typically we have, we as a company have mainly spruce and pine, but there are others also using larch as well, let's say. And there are different types of pine. Let's say in South Africa or in Africa, we have different types of pines than you have in Australia or also in the US. Now the topic, how do we process trees? First of all, I found a nice picture of how trees get processed. I only have it in German, but I will try to translate. So let's see, that's how trees are getting cutted with different sections. So basically important to know is around about 60% of the tree is primary material and 30% of the tree is secondary material. That means dust and everything else. So as we can perfectly see here on the picture, for example, typically CLT, let me check if I get here a laser pointer. Typically CLT would probably be one of those boards, let's say, and glulam one of those boards, depending a little bit on the section. So you do not cut out 100% of a tree, just CLT or just glulam. And that's also how our company is structured. So we as a company are structured to use 100% of the raw material. So we are directly starting, I will go more in detail later on, with the forestry service, reforestation and harvesting. Then we go into the sawmills, into the sawing products, into the timber construction products. That's the most interesting part of this webinar, let's say, but also into biofuels and pallets, for example. This brings me to the division like you've seen at the tree. So it is not 100% out of the tree is a structural timber. And this brings me to the different pillars that we have. For example, we're starting with a tree nursery. We're having our own forest management. Then you have basic products where you have just lumber. Then you have the DIY products, construction solutions, also biofuels and pallets. Here some pictures. That's, for example, how we are processing the trees. Let's say here we're starting with our tree nurseries. And then in the most countries that we are operating, we have our own cutting companies. They are going into the forest for harvesting and bringing them to our own sawmills. Here to get a little bit an overview, I've prepared you some of our sawmill sites. For example, that's our, on the left hand, that's our headquarter. To give you a number, this sawmill cuts around about 1.05 million cubic of trees a year. That's between 5,000 and 6,000 cubic per day. And if we divide it, that's, for example, around about 200 trees an hour. Brings me to the numbers. 50 million trees we are setting each year. And we are producing around about 5.2 million cubic of lumber, which means between 7 and 8 million cubic of trees cut down. And as we heard already before, the numbers, I think important here to understand is that it's not only CLT, because if I take this 5.2 million lumber and take the glulam numbers that we are doing and the CLT numbers, we are at 600,000 cubic, let's say. Let's round it up, it's 10% of our business. So important to understand is not 100% of it goes only into this high level manufactured timber products, so to say, if we want. So important is the diversity, and I think the diversity you perfectly see here with the numbers. I can show you a little bit of how, as we were speaking so much about numbers and how our finished lines look like. That's, for example, a 3-layer production. That's our glulam production. It starts here and ends here. Get a little bit of an impression. That's our CLT lines. I think important to understand, if we go into the topic how to process trees to get engineered timber products out of it, I think better the input is, better the output is, and that's relevant for the whole chain of processing the tree. So better I'm able to control, or let's say diverse my products through the chain, better on each single product I have the products ready for me to use. Thanks for the attention. I know it was quite short, but I think otherwise I would talk a third time about the CLT production, and we already had 2 good presentations up front about it. So I think not worth seeing a third time the CLT production.
Thank you very much, Wolfgang. Yes, it was short, but I hope you wouldn't mind when we call you back to make a more detailed presentation in the future, because we'll be having better and more training oriented webinars later. Thank you so much. we welcome again all participants to this webinar, the third in the series of the Mass Timber Construction in Nigeria webinars. Should you have missed out something, we are going to spend the next few minutes to recap what we have heard from the three presenters today. So over to you, Abiodun.
Yes, thank you very much. Can you hear me?
Yes,
Hello?
we can.
Thank
Yes,
you.
we can.
It's been very educative. The first speaker who was absent spoke to us about mass timber construction in Europe. He spoke about construction being reimagined and renewable, telling us how timber is revamping the construction industry, looking at the materials and the technology and different construction processes, especially the prefabrication. He spoke about the qualities of timber that makes it suitable for construction, which spans from the stiffness and the strength that makes it easy to be able to withstand strength and gives it that advantage for construction. He also spoke about how it is fabricated, you know, from the tests that they need to carry through in the factories, measure control. He spoke about the cleaning and how they have to glue the timber to make sure that they have it in desirable sizes for length and thicknesses, and how we saw videos of the processes in the factory where the wood is being put in through all these processes and prepared for usage on site. The second speaker spoke to us majorly about off-site construction techniques in mass timber. He spoke about the machinery that is used to work wood to the desired effects that we want, that we desire as designers. He spoke about the CNC machine, the processing robots. He spoke about how timber can be mostly prefabricated, and he showed us various examples of how his company has done that. Finally, we heard from Wolfgang, and he started by talking to us about the species of wood. He spoke about the conifer, which is the soft wood. He said it's soft, it's easy to process, and is lightweight. The other one, which is the broadleaf tree, these are the hardwood. He said the hardwood is harder than the conifers, and he said it's also heavy and it's quite difficult to process. He showed us different examples of how this wood has been used or put to good use, and also he rounded up by showing us examples and pictures of projects that they've handled. Thank you. Akmo.
Thank you very much, Architect Abiodun, for that summary. Now, I will call on Architect Abimbola Ajayi to make a few remarks on behalf of mass timber construction in Nigeria. Architect Abimbola.
Thank you, Architect Moradeke Okunriboyi. Once again, I want to say a big welcome to everybody on the webinar, both on YouTube and on this Zoom channel. I want to first of all thank all the speakers and Architect Moradeke for moderating this session. We have so far had, this is our third webinar in the series. And like she said, my name is Abimbola Ajayi, and so far we've had very pleasant journey of knowledge impartation in this circular economy of sustainable construction methodology called mass timber construction. The whole idea is that we want to start the conversation in Nigeria because actually this methodology is making waves in other parts of the world, in Europe, in South Africa, in America, and even in Australia and way beyond. So we believe that once we start this conversation and we create awareness, we engage interests of construction industry professionals so that they can start thinking differently in the way we procure our buildings, and so that we'll have more sustainable construction methodology. So far, it has been really engaging. It has been mind-boggling because sometimes I wonder, is it really possible? But of course, we've been having timber construction for centuries, but now we have more stabilized materials for the construction methodology. So I hope that our participants will remain focused and their interests will be engaged further. And we should start thinking of how we can implement this strategy or this methodology in Nigeria. And looking at how we can work on the policies, how we can work with schools of architecture, how we can work with forestry professionals as well, because we need to inculcate the culture of seed to house. That was what one of the lecturers told us about a couple of sessions ago, having seed, to house. So I believe we can do it in Nigeria, and most probably even better than other parts of the world. So on this note, I don't want to take too much of our time. We have been very good with timing today. We've had 3 presentations today, and in future, we are going to have 3 more webinars before we close this module. This is module 1 in the 2023 webinar series on mass timber construction in Nigeria. We have had introduction to mass timber construction in July. We've also had forestry, how to prepare the forest for mass timber construction. That was on the 2nd of August. And then this one, webinar 3, how to process trees to create engineered wood processes. Now, the 3 other webinars will be designing with timber. How does this timber require different thinking by architects and engineers? And then another webinar will be building with timber, effective assembly with less waste. And then the last but not the least module will be opportunities for mass timber construction in Nigeria, with a special focus on Lagos and Abuja. So on this note, I will hand this session back over to the moderator. I want to say a big welcome and a big thank you to those who are participating. And at your leisure or at your time, at your convenience, please visit our YouTube channel where you can listen to previous webinars for reminder or the education, so to speak. And I hope that as we are engaging your thoughts, engaging your professionalism, engaging your creativity, you'll be engineered or interested in actually making this a reality in Nigeria. Thank you very much. God bless you all. Architect Mo. Moderator, over to you, please. I'm sorry, did you all hear me when I spoke?
Yes, we did.
Okay, moderator, over to you,
You
ma'am.
broke up
We
some
did.
time. Okay, thank you, because for some time I actually wasn't hearing anything that she was saying. But thank you very much, Architect Abimbola. And I hope the participants are able to understand what this is all about. This is just to call your interest in mass timber as a product for construction in Nigeria. We're now moving on to the question and answer session. This will be taken by Architect Abimbola Ajayi and Architect Ebenezer Odeyale. Over to you. I think they'll just be reading out the questions that have been put in the chat boxes, both on Zoom and YouTube. And then our panelists can answer the questions. Thank you.
Okay, can you hear me, please? Can I just have a wave if you can hear me? Because I wasn't sure if I was heard the first time.
Loud and clear, ma'am. Loud and clear, ma'am.
We can hear you.
Okay, thank you very much. Firstly, I must appreciate everybody once again. And Architect Toyi Emmanuel Popola just put in the chat box that this webinar has been a great time out. Thank you so much for your compliment and for the encouraging words. And we'll try to ensure that even future webinars will be greater for everybody. Now, very quickly to the questions. Ibukun Faloye asked the first question. Moderator, can I take all the questions together so we can save time and then the speakers can answer us?
Yes, but you need to keep a tab on the questions that have been answered so that if anyone was left out, you can draw their attention to it. Thank you.
Okay, so I'll run through. For now, we just have 5 questions. Can you hear me, please? The first one was from Ibukun Faloye. Yes. Ibukun Faloye asked, how are the pre-graded timber protected against fire to the extent that in case of fire, only the exterior of the timber chars, leaving the core inner part intact? That's the first question. Then Architect Oliaku asked 2 questions together. She said, what do you do with the dust accruing from the production process? What do you do with the dust accruing from the production process? And then her second question was, if you have assessed production in Nigeria, what are the limitations that you have noticed? The third question came from Yoktan Nyodwi, who said, what are the treatments for the sides exposed to extreme heat, such as the kitchen firewalls with installed cooking stoves? I repeat, what are the treatments for the sides exposed to extreme heat, such as kitchen firewalls with installed cooking stoves? The fourth question is from our moderator, Muradeke. She said, since bamboo can also be cross-laminated, can it pass for mass timber? Since bamboo can also be cross-laminated, can it pass for mass timber? Then the fifth question was from Ademola Adeleye, who asked, how do you handle substructure in mass timber construction, particularly in waterlogged areas? How do you handle substructure in mass timber construction, particularly in waterlogged sites? Sorry. So those are the questions for now. If we have any more questions, I will call your attention. Over to you, to the speakers.
It's Jamie here from XLAM. I'll have a stab at some of those questions. Our sawdust, we actually sell it on to chicken farm and to horse farms. If you have larger quantities of sawdust, that could be used as an additional product. As far as building in wet environments, you always want to keep the timber raised above the wet surfaces. So if you are in waterlogged areas, you have to raise the base of the building off the ground. And then the heat issue in a kitchen, I wouldn't typically leave the CLT exposed. If it is going to have fluctuations in high heat and then low heat, you will dry that section of timber out considerably quicker and it will crack and not look great. If you are putting a heat source in one of these buildings, then you do need some skin in between the heat source and the CLT. So quite often you'll go into a building in Europe and you wouldn't even know it was CLT. The walls have kind of a drywall boarding in front of them or something like that. And these are more heat resistant products. So it's the buildup that you would use on that type of structure. Thank you.
I think then we only missed the
Thank you,
bamboo
Jamie.
question, right?
Architect Amibola, can you read the question on bamboo again, please?
Since bamboo can also be cross-laminated. Now, I think generally bamboo is considered as grass, if I'm not wrong, and not as a tree. I think basically you can do a lot out of each product or each tree. It depends if it makes sense or not on high quantities or on low quantities. That's a basic answer. I think a lot of trees has been tested to make CLT and glulam out of it, and it works structurally, but if it makes manufacture-wise with high quantities, that's the second answer that needs to be taken.
Okay, thank you very much, Wolfgang. Mr. Abimbola, is there any other question that's outstanding that has not been answered? And I think some comments are coming in. Maybe you want to take those too. Please unmute yourself, Ma.
I'm sorry, I didn't know I was muted. Okay, yeah, Nessa made a comment and said we will need regulatory framework and regulation for quality control because quality control has been a general challenge in Nigeria. And the response was, yes, you are very correct. We hope that the relevant government agencies will look into this and buy into it because the International Building Code already recognizes this construction methodology and sustainable mode of construction. Now, I hope that answers or that addresses what Nessa is trying to say. Now, another set of questions, 3 questions in one by Adedolapo Oladipupo. It says, 1, can this method be used for affordable housing? Number 2, what treatment takes care of water and mold growth, which leads to respiratory diseases? 3, does CLT emit VOCs? I don't know what VOC is, I'm so sorry. Permit me, I need to learn what that is. But does CLT emit VOCs? So those are the 3 questions in one. And I think that would be that for now. Thank you very much.
So it's Jamie here from XLAM again. We have actually done a few prototype projects which are affordable housing. CLT is an expensive material if you're just doing individual small projects, but on scale, it does make sense. So yeah, we have done versions of it. It just needs the volume, the scale for it to make sense. As far as mold growth goes, timber, when it's above a certain moisture content, will allow mold to grow. So you want to try to keep it as dry as possible. There are requirements in South Africa to have treated timber as structural timber. So we do put kind of a boron-based treatment or a copper chrome arsenic-based treatments onto the timber. Some of these treatments aren't allowed in Europe. The CCA is one that's not allowed in Europe. We try and go for the boron more than anything else. It's the healthiest. And as far as VOCs go, I don't believe there are any VOCs that come out of the CLT. Most of the VOCs would be related to the adhesives that you're using, but the polyurethane adhesive, if I'm correct, has no VOCs.
Maybe I can, Jamie, if you mind, I can add one point on the VOCs.
Please.
VOCs sometimes have a bad attitude, but they are VOCs not automatically negative. If you go into the forest and you smell, do you feel good or you feel bad? And if you measure in the forest the VOCs, your measurements will explode, because VOCs depends just on the type of material that you use. So for example, if you use pine gives you a lot of organic natural VOCs. If you use spruce, the value is very low. So VOCs typically are coming from a complete different industry, or this negative habitat of the VOCs are coming mainly from the panel industry, from the internal furnitures, and there the VOCs were related to melamine, so to the glue. But we have to separate this, I think. And what Jamie answered correctly, the polyurethane, where the VOCs relation originally comes from, doesn't emit any VOCs. Polyurethane glue, let's say.
Okay, thank you. Thank you very much. There are two questions that are still yet to be answered. If you have assessed production in Nigeria, what are the limitations you have noticed? Maybe Mr. Faloye can help us with that question, because I know that Jamie and Wolfgang most likely don't have answers to the production in Nigeria. And then what are the treatments for the sites exposed to extreme heat, such as kitchen firewalls with installed cooking stoves? Maybe Jamie or Wolfgang can help us with those questions. And then what do you do with the dust accruing from the production process? So 3 questions are unanswered. What do you do with the dust accruing from production process? Number 2, what are the treatments for the sites exposed to extreme heat, such as kitchen firewalls? And then if you have assessed production in Nigeria, what are the limitations you have noticed? Over to you, Jamie, Wolfgang, and Mr. Faloye.
Thank you. Do I go first? Or
yes.
Wolfgang go first. Wolfgang, okay. Now, as with regards to the question directed at me, which has to do with in Nigeria, I want to believe that the issue of standard is very, very particular. Standards in forest management, standards in construction, and this is why the building codes have to be properly looked at. This will take place with the public sector, with private sector stakeholders, to ensure that a proper review and modification of the building codes can come up. Don't forget that fire could be a big problem, but because it is mass timber, we found out that mass timber has this quality to char only on the outside, leaving the core interior unlike in structures that have concrete and steel to melt, and but mass timber stays intact. To the extent that not long ago, a test took place in California to see how mass timber will react to a situation of an earthquake. This test was beamed all around the world. It was successful, and such tests have to be done in Nigeria. Not necessarily earthquakes, because Nigeria is not an earthquake. It's not earthquake prone, but relevant tests that will give it certification to be passed by the relevant authorities, such that mass timber can actually be assimilated and certified as a construction material in Nigeria. The relevant authorities have to go through all this testing, acoustic, fire, all this has to be done before we can get there. I think we are just starting. Thank you very much.
Yeah, thank you. I think the next one, Jamie already answered both, but I can try it in another way. Treatment for the sites exposed to extreme heat. General explanation, nearly every material has a self-burning value, if we want to call it like this. That means on a certain heat value, it automatically begins to burn. For example, I think spruce, the value is around 450 degrees. That means if I'm over 450 degrees, the material automatically starts to burn. What we have to imagine here is that we have a compressed timber product. So everyone basically, as a primary answer, if you go and take a light and try to burn up the CLT, I think it will be nearly impossible for you. So you need a high burning surface to burn this material as an initial answer. What do you do with the kitchens? I think there it is, the answer would be how far it is away. So how far you have to fire away from the timber material. Like Jamie answered before, if we take it directly in front of the burning place, it would be valid to revest the timber with some other material, like it is very often done. For example, with gypsum and then with some tiles. What do you do with the dust? We do it differently than Jamie. So we are within our company, let's say the dust typically is used or for pellets or briquettes, or also goes directly into electricity or heat production. I hope this answered both questions now.
Okay, thank you very much, Wolfgang, for those answers. And I also want to thank Jamie and Mr. Fallow again for their contributions to some of the queries that have come from the participants. We're about to round up the webinar, but before we go, I would like to take a couple of messages. I think I want to invite Dr. Folúṣọ́ Awẹ́, who I find to be participating. I know Dr. Folúṣọ́ Awẹ́, I believe he's the same person. He's both an architect and a civil engineer. So can you just give a few comments on this, topics that have been discussed today? And if you have been on the other webinars, maybe you want to have a word. Dr. Awẹ́, please unmute yourself and just give us a word. Thank you. Again, it's a form of feedback for the facilitators of this webinars, at least so we know what the participants are thinking. Dr. Awẹ́, you have a minute or two.
Thank you, Ma. I'm sorry, I didn't join the last one, I missed it. And this one again, I came late because of pressure of work in the office. But the little time I've spent, I think I enjoyed it. is a good opportunity to explore this timber as a building material. There's no doubt that the presenters, they have actually done justice to the topic, and then the level they are, I think, is a good one. And also the questions that participants have raised, I think they need to work on them, particularly management of dust. We all know that when our environment is polluted, we inhale materials that are not healthy. If those managed, then we can actually, be in a good environment. And also, we know that timber cannot be compared with iron bars or reinforcement, but with adequate treatment, then they too can function. During the olden time, we know that our fathers and our parents, they actually use timber, most especially in constructing staircases and also in floor slab, or the first, what they call it now, the upstairs, they are still standing for years. That shows that timber has a great potential, to be used. So I really appreciate this webinar, and hopefully in future I will join on time. Thank you very much. I appreciate it.
Thank you, Doctor, for your comments. They're noted, and we honestly really would hope that you will join us. You have a peculiar position, being an architect and a civil engineer at the same time. We really would like, and you are also an academician. I think you have a very interesting position, and we hope you will partner with us and in moving on with this product. And there are two other people that I'll be calling to give their comments. Architect Bosede Idegbeso, she's the convener of Wood Expo Nigeria. Architect Bosede, can you give a word, please? Please unmute yourself and give us a word. Thank you. Architect Bosede.
I think she's no longer here. I'm not sure.
Okay. Okay, all right.
Oh, she's here. She's here. She's here. She's here.
Thank you. Architect Bosede, a word from you.
Architect Bosede, please. We're waiting for you.
Please unmute yourself.
Moderator, please call the second person if she's not available.
Okay. Well, I would also like to welcome Architect Lanre Godman-Olushola, who is the Director at Large AIA International Region, to give a message. Thank you. Architect Lanre Olushola, please.
Good afternoon, everyone. Good morning, good evening. Thank you for having me. It's been a wonderful time attending this program organized by Wood Expo Nigeria. And I really am happy to be a part of the webinars that had gone on like 3 times now, and I look forward to more of these webinars. But what I want to bring to the table for Wood Expo Nigeria is let them know that the AIA supports events like this and encourages organizations, institutions, associations to carry out educative programs and innovative programs like this one to enrich members and non-members of the American Institute of Architects all over the world. The AIA has presence in every part of the world outside of the United States. And I am in charge of the Africa and the Southwest Asia section of the AIA. So we always encourage to have programs that would accrue CES credits to members. Attending programs like these, members can earn LUs and HSWs if you are a member of AIA, wherever you are attending from. For example, I see that we have speakers from Austria, from Australia, from South Africa, and this is quite rich, you know, listening to what each of the speakers have to offer. So I want to encourage Wood Expo Nigeria to partner with AIA, because many members I see here are all members of AIA, and you can earn your CES credits, which is a requirement for your renewal of membership every year by attending events like this. So if you would like your audience to gain learning units, credits, HSW, health, safety, and welfare credits from your events, please, you know, partner with AIA. AIA is open to do all those kind of partnership. We will arrange that, and members can earn credits for attending webinars like this. And of course, the Wood Expo Nigeria events will gain global recognition. We have over 50 members attending this. That is quite large. I commend you for what you are doing, and I appreciate it for allowing AIA members to be part of this. Thank you so very much.
Thank you, Architect Larry. We'll just be rounding up now. I want to say thank you again to our panelists, Dr. Paul Kramer, Jamie Smiley, and Wolfgang Heidenstreit. I want to thank Architect Biodun Fatui, who has recapped what was presented by the three panelists. I thank Mr. Ibukun Falwe, who has been very instrumental in bringing the panelists on board. Architect Abimbola Ajayi, thank you so much. And then everybody who has participated in this webinar. Again, if you would go to YouTube, just type in Mass Timber Construction in Nigeria, and all the recordings of the three webinars would pop up. You can go through them again and learn one or two things that you might have missed in the past webinars, and get them to whet your appetite for the coming webinars. Architect Bimbo had mentioned what the other webinars we'll be looking into. We'll be looking at design, and we'll be looking at manufacturing, as well as the opportunities that abound with mass timber construction. Again, I hope that you will join us in another 2 weeks when the next webinar will be coming up. As usual, flyers would go out to remind everybody to register, and that we also implore you to share these flyers with your friends and with those people who you come across who just may be interested in this. This is something new to Nigeria, and we would like there to be a groundswell so that we can get into it. Jamie had mentioned to us that they had to start small in South Africa, but then they're already supplying to so many countries and different projects. And I think it's also possible. Nigeria, we've got all kinds of wood, softwood, hardwood. And if we have all of this abounding, then there is something that we can make of it, and we can come on board. Again, we will be preparing ourselves for the next phase in business outreaches in Africa, that will be coming upon us in a very short while. Thank you again so much for your time. Thank you for listening.
Moderator.
Thank you for joining.
Moderator.
Yes.
Moderator.
Yes, ma'am. Yes. Yes,
sorry, very quickly in the chat box, the chairperson of the Association of Professional Women Engineers of Nigeria, APWEN Lagos chapter, she's in our midst, Engineer Monsura Abimbola Alagbe, and she's thanking us and she's thanking the organizers of this webinar, and that is a wake-up call to go back to the basis when timber was massively used for flooring, and they lasted and are still standing the test of time. So she says, thank you and God bless you. Engineer Monsura Abimbola Alagbe, the chairperson of Association of Professional Women Engineers of Nigeria.
Thank you.
Lagos chapter.
Thank you. Yes.
Thank you, Madam Moderator. Thank you. Yeah.
Oh, it's so nice to hear your voice. Just give us a word before we go, ma.
Yeah, that's good. Yeah, thank you so much, ma. Like I said, well done, well done, well done. In fact, you know, it's been seen all over the world, especially in the developed country. You know, there was a time I saw some barriers. I thought they were made of concrete. Honestly, it was when I got closer, I realized they were made of timbers. But over the ages, maybe the depth over it, and it looks so strong. And I remember my grandmother's house in Ibadan, that the flooring were made of wood, and they're still there. Even before my mom was born, it had been there. So when I heard about this, it was my past chairman that actually shared it on our platform. I saw it this morning and I quickly registered that, wow, this is a great thing coming to Nigeria. So Ma Ajayi, I really appreciate this, and all other, you know, members of the group. I really appreciate this. And like you rightly said, we will need more of this. The processing, then how we design, you know, from the design stage, then to construction, to post-construction. It's a welcome idea. Thank you so much, ma. God bless you. I really appreciate this. Thank you.
Thank you, engineer.
Thank you.
One thing.
Moderator, over to you.
One thing that. Okay, thank you very much. Thank you, engineer. One of the things that we're looking to is collaboration among the professionals, especially in the building industry. So we hope that you will be an ambassador and you know, talk about this in your group, and you know, get the engineers to come on, because it's going to be absolutely impossible for us to continue on this path without the collaboration of the engineers. We would need the planners, we need the quantity surveyors, we need the policy makers, we need, and you know, all of these people are people who are among us. Some of them are in the public sector, some in the private sector, some in academia. All of these people, we need to come together to look at how we will foster this conversations, you know, in Nigeria. Thank you so much, everybody, for coming. Have a very wonderful evening. Bye-bye.
Thank you.
Bye-bye, everybody. Thank you so much.